$200 billion worth of fertilisation per year they do for us for free. And so in America, it turns
Visiting all those flowers, crops, whatever.
Bringing them all back. And in America, it turns out that it is more profitable for beekeepers to rent the beehives than to use them to make honey. And so there's this massive movement of beehives in America and in Australia. So they come from Queensland down to Mildura and back again. And typical numbers are for a square kilometre of apples, 250 hives to pollinate them. For almonds, 500.
Okay, that said, Madeleine, bees, certainly in the Northern Hemisphere, are under extreme threat at the moment. Why? What's going on?
Well, I think they have been for quite a while, but it seems to accelerate. The main problem is, well, there's a lot of problems, but it all started with a tiny, tiny, tiny little things, probably about this small. It's called a varroa mite.
A mite?
A mite.
What's a mite? Is it an insect?
No, it's more related to spiders and ticks. It's actually the tick of the bees.
So it's got 8 legs instead of 6?
It's got 8 legs. It's actually a beautiful creature.
But not for bees. Okay, so it attaches itself to a bee.
And it drinks its blood. So it's sort of similar to the mosquito drinking your blood.
And delivers a virus.
No, it transmits the virus. So it's similar. Just say you have malaria, a mosquito bites you, drinks your blood, the malaria parasite gets into the mosquito.
Yep.
The mosquito then bites Carl.
Yep.
Carl gets malaria. And in the same way...
It's the vector.
It's a vector. So it transmits the virus from bee to bee.
All right. So, and what does this virus do?
And the bees come out with deformed wings. So the virus is known as deformed wing virus.
So what, they can't fly?
They can't fly.
So they can't pollinate?
They can't do anything. And they die really young. So it's a big problem. But the interesting thing is, the virus is much older than the mite. And it's only since the mite arrived that the virus has become a problem.
So to eliminate this problem then, you've got to attack the mite. How is that being done?
Yeah, or the virus. We think.
Okay.
We're not sure. But what people do now is they have to try and keep the number of mites low. Because it has something to do with the number of mites and the number of times that the bee gets bitten by a mite. If you have a large number of mites, the bees become sick. So you have to keep the numbers of the mites down as much as possible.
How large is this threat to bee colonies, certainly in the Northern Hemisphere?
Well, for commercial beekeepers it's a big problem because they need their colonies to be large, they need them to be strong because they rent them out to, say, almond growers for pollination. They have to treat their colonies with a large number of miticides, so that's a pesticide that's targeting mites specifically. If they don't do that, their colonies will basically die.
So I mean, we're talking about colony collapse here, aren't we? And the effects that this could ripple across the globe. Is the mite or the virus present here?
No.
Why?
Wow.
Well, the mite's not here because it doesn't originate from here. It originates from Southeast Asia. And there's a great example of bee researchers, so I have to feel a little bit guilty causing a lot of problems because in the 1980s people mixed the 2 different species. The species that originated or that still lives in Southeast Asia normally occurs with the mite. No problems at all. Mite doesn't cause any problems. Bring 2 different species together, mite jumps to another species and everything goes wrong.
So are you concerned then it's only a matter of time before it makes its way here? I mean, clearly we're protected at the moment because of our isolation.
Yes, but New Zealand has it. If you look at the map, New Zealand is much better isolated than we are. And they got the mite in 2000. And the irony is that the mite comes with the virus because it sits in it. So then the mite starts biting, the virus is released, and it's all downhill.
So it's an issue of biosecurity. How do we defend bees here in Australia?
Well, that's one issue, but there's only so much we can do. Because again, if you look at the map, New Zealand is this blob in the ocean. If you look at the map of Australia, especially when you look up north, there's all these islands. And bees can hop islands because they can fly large distances.
Now, you mentioned that the virus was around before the mite. Are they doing some sort of weird evolutionary biology together where one impacts on the other?
That's what we think. So if you have a virus and it's co-evolved with its host, the funny thing about viruses is If it kills, because it can't live by itself, it sits in the bee, it needs to be transmitted to another bee. The virus normally needs the honeybee to stay alive long enough to be transmitted. So the idea is that selects for viral strains that don't kill the host too quickly. Bring in a vector. Now that vector does it for you. So this now can still transmit the virus even if the bee is half dead, because the virus now sits in the mite and the mite happily walks to another bee.
Yeah.
Wow.
So the idea is this now selects for more virulent viral strains.
Evolution in action.
Exactly, that's exactly right.